Hello, Caymans, Mr. Eicher here, coming at you with a lesson, Chapter 4, Section 2, Part A. This section we'll do in two different videos, two different lessons. So if you have the class notes for dividing monomials and dividing polynomials with long division. So in this chapter about polynomials, we've started by talking about operations, addition, subtraction, multiplication, division. So when dividing a polynomial by a monomial, one term, divide each term and use properties of exponents to simplify. So for instance, on question number 1, this xy is a monomial, and a sum or difference of a bunch of monomials is called a polynomial. So we have a polynomial divided by a monomial. We're going to divide each term by xy. And then use properties of exponents to simplify. So we can divide this first term, the x's will divide out, and the y's will divide, and you'll have, that's 2 on the top, 1 on the bottom. So you're going to just have 1 y left in the top. So this first one's going to be 5y. The next one we can divide a y in the denominator. The 1 in the numerator becomes a 2. And you have a x left over in the denominator. And then the next one we're going to divide this x to the first is going to subtract with that x to the second. This x to the third is going to become x squared. So we'd have plus 3x to the first y squared. It looks like this is our simplified answer, dividing a polynomial by a monomial. Question number 2 is a try this for you. Divide each of those terms by 4xy. Number 3, again, notice we have a polynomial divided by a monomial. So we're going to divide each term, 12mn cubed. We're going to divide each term by 3mn. So dividing each term, 12 over 3, you get a 4. The m's divide out, and you get an n squared. 9 divided by 3 is 3, mn. And then 15 over 3 is 5m. So it looks like this would be our final answer, dividing a polynomial by a monomial, 3mn. Number 4 is a try this example for you. Notice that the -1 exponent, that's going to create a polynomial. And again, since we have an exponent of -1, that's going to put that negative AB in the denominator. And then you'll divide each term by negative AB. And when you divide, make sure you switch the signs because of that negative. So that was the first part of the lesson, just dividing each term by a monomial. And the last part, we're going to divide two polynomials. So dividing two polynomials, there's two approaches. We're going to do long division, that's today's video, and then synthetic division is the next video. And we can use long division for any polynomial division problem. It doesn't matter what you're dividing by, whereas synthetic division, you can only use it in certain contexts. So let's see what this looks like. First, let's just review how to divide, division review. So 3248, and we want to divide by 21. Probably need a little more space than that. divide by 21. So you'd ask, how many times can 21 go into 32? So that would be 1. So I put a 1 here, I multiply to 21, and then I write that right here. And it's important that you realize you're going to be subtracting the 21. So if you subtract, you get 11, bring down the 4, and really we could bring down the 8 as well, bring the whole thing so we don't forget anything. And then how many times does 21 go into 11? Nothing, but 21 goes into 114 5 times. So 5 times 21 is 105. And we can subtract, we get a 9, bring the 8 down one more time. And then how many times does 21 go into 98? I think it's 4 times. So 4 times 21 is 84. And then we subtract. Again, notice it's important for the next process we're going to do that you realize we're subtracting here. And then we get a 14. Now we could put like a 0.0 and keep going, but we would call this our remainder, this 14. So we would have an answer of 154 and 14/21. And we could simplify that to 154 over 2/3. And that's fine, but really it's the process. The main things I want you to realize is we're subtracting each of these. The last number we get is our remainder, and we put the remainder over what we were dividing by originally, 21. And then each of these numbers that we chose, each of those numbers we multiplied with that 21. So this process for long division is going to be really, really similar to what you've done with long division in the past. So let's look at number 6. First thing, the question is, what should we put here that multiplies to x squared that will give us x to the 4th? So what times x squared is x to the 4th? So we would start with an x squared. We're doing x squared there because x squared times this x squared is x to the 4th. And then we also multiply this x squared to the 2 out in front for this process of long division. So when we multiply that, that would be plus 2x squared. All right, so then we're going to draw a line here. And remember, we're going to subtract. So both of these signs switch, subtracting here. So then subtracting down, we have no more x to the 4th now. X to the 4th minus x to the 4th is 0. We have x squared minus 2x squared is negative x squared. And then we'll bring the other stuff down. Now we do that process again. Doing that process, we want something here that multiplies to x squared to give us negative x squared. So the number we need there is a negative 1. Negative 1 times x squared is negative x squared. And then it also multiplies to the 2. So minus 2. I'm going to put that over here since it's going to be a like term with 5. So then I'm going to subtract, and when you subtract, the signs change. So then adding down the columns, we get a 0x squared, we get a negative 3x, and we get a plus 7. When do you know when to stop this process? You know to stop this process when the divisor, this exponent right here, this x squared, is larger than the exponent on this one. So the x squared, the 2, is bigger than the negative 3x to the 1st. So this is actually finished. What we call this bottom part, this is our remainder, just like we had in the previous one. So we would write our answer as x squared minus 1, all that stuff in the top, plus the remainder, negative 3x plus 7, divided by what we originally were dividing by, which is x squared plus 2. So this is your answer to that division problem. So if you wanted to, if you actually multiplied this to this x squared plus 2, you would get this polynomial, x to the fourth plus x squared minus 3x plus 5. This polynomial division is an important skill. If you take calculus, long division could be a helpful thing to help you take derivatives and integrals. But also, in this class, we'll use this long division because graphically, this remainder and this x squared minus 1, it tells us something about the graph of a polynomial function, which we'll talk about later in this chapter. All right, let's look at another example. We have x squared minus x plus 2 is our divisor. So we want some value here that when we multiply to x squared, we get x cubed. So that value would be x. So then if I multiply that, I'm going to multiply it to both of these, or all three of them actually. And we would have x times x squared is x cubed. X times negative x is negative x squared. And x times 2 is plus 2x. And then we subtract, we change the signs and add down the columns. So that's a 0, that's good. Negative 4 plus 1 is negative 3x squared. 5 minus 2 is plus 3x. And then minus 6, bring that down. Next, we want to know what value should I write here. So something times x squared gives us negative 3x squared. So that sounds like we need to multiply by a negative 3. Negative 3 times x squared, that gives us negative 3x squared. Multiplying those. And multiplying these, that would be a plus 3x. And then multiplying these, that would be a negative 6. And then when we switch the signs, because we're subtracting, so all the signs flip-flop, and we add down, we get a 0, a 0, and a 0, so our remainder is actually 0. So what that tells us is our answer is x minus 3. That means if you did x minus 3 times x squared minus x plus 2, if you actually multiplied that out, that would be this polynomial that we have right there. So that's the process of long division. We have a couple more examples on the second page. We have 3 more examples. I'm going to get you started on number 8, and then you'll finish it as a try this. And then we'll look at number 9 together, and then number 10. We'll see how you can do with that as a try this. So for number 8, we want something multiplied to c to give us 2c cubed. And that sounds like we need to multiply by 2c squared. 2c squared times c would be 2c cubed. And that multiplies also to the negative 2. It's basically the distributive property minus 4c squared. And bring down the other stuff. There we go. And when you subtract, all the signs change. So that would give us a 0, a 1c squared, a 0, and then a 0. Got a lot of zeros there. That's pretty nice. So now we need to figure out what we should write next to the 2c squared. So if we multiplied by c, we would have c times c is c squared. C times -2 is -2c. And then when we subtract, signs change, we get a positive 2c. I'd like you, as a try this, to finish this part. What should I include here? That part itself will be your try this. You may or may not have a remainder. So you could try that, see how you do, but it's almost done. Number 9, we have something times x to get x cubed. So what should we do? If you're struggling with that, basically you're doing x cubed divided by x, and that will tell you what you need to include in that circle right there. That circle would be x squared. Then we distribute that x squared to both of these terms. That would be x cubed minus 3x squared. And then subtracting, we switch the signs. Now when we subtract, there is no other x squared term, and there is no number to combine with the -27. So we just are going to bring down this 3x squared and bring down the -27. Since they're not like terms, they can't really change each other at all. And then next we need something times x to give us 3x squared. That sounds like it would be a positive 3x. So multiplying these, we would get 3x squared minus 9x. And then we'd subtract like terms. So that would be at 9x minus 27. And then finally, you have plus what times x to get 9x. And that would be a 9. And that distributes to both of those terms. So we get 9x minus 27. And we add or subtract, sign switch, and we get a remainder of 0. Remainders of 0 are nice. So our answer is all of this up top is our answer. So all of this, our answer is x squared plus 3x plus 9. So dividing x cubed minus 27 divided by x minus 3, that equals x squared plus 3x plus 9. And that would be our answer. The last one for long division is this one. To divide, this is a binomial, 2 terms. And then this is a polynomial, many terms. We can set it up first, the divisor. The divisor is the part in the bottom. It's the divisor goes on the outside of the box. And all this stuff goes on the inside. And this is a try this, but let's do the first step together, and then I'll let you finish it as a try this. So the first thing, what should we write? Right here, something times x squared to give us 2x to the 4th. We would need a 2 and an x squared. And then when we multiply those, we would get 2x to the 4th plus 4x squared. and then we will subtract and the signs switch. Make sure that you add or subtract like terms. So actually we could kind of shift this 4x squared underneath. Might be a good idea just to put it underneath 4x squared, the other x squared. This is a minus sign now. So when you subtract down the columns, there is no other x cubed term. It would be a minus 5x squared, and then plus 2x minus 10. So as part of your try this, you're going to finish, you got 2 more blanks, I would guess. And this one probably will have a remainder, but we'll see. I'm not sure yet. But if you finish that as a try this to show us that you're familiar and you know how to do the process of long division. Thanks for watching this video. See you next time.